Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and I'll now turn it over to the speaker for introductions.
All right. Hello, everybody. I am Sam Wronski. I am a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. So what we're going to be doing today is experimenting with a few of the new things that came out in build. Specifically, we're going to be taking a look at Azure Container Apps, and we're going to try to put this app that I have been building into a web service, into a container, and then into Azure Container Apps. This is probably a process that might take more than the hour that we currently have, but this is going to be kind of walking through the process and kind of going through all of that. Just to quickly touch on what this is a really quick app. Currently, it's just a console app, so I can actually just pull it up. And what it does is generate a SVG or vector graphic outline of your GitHub activity. So you might have seen those green dots on your GitHub showing the activity of what you've done over the past year or so. This does that, but it does it in 2D and gives you a bar graph, and then renders that to a graphic, and then you can do fun things like put it on a bookmark, for example. And so then you have your commit history all over in bookmark. Anyway, so we're doing that, but I'm trying to put it into a service so that it's more accessible, just because I think it'll be better that way. So again, it's currently in a console app, and the problem with that is you need a personal access token from GitHub in order to use the API. And so because of that, I'm not actually going to show you the tool entirely working, because I don't want to show a personal access token here. There's just weird things that can happen if people get a hold of that. But we are going to kind of just quickly talk about what it does and show how we can kind of migrate that from the console implementation into what we currently have. So that's sort of the path we're going to be going on. So this is what we currently have. Let me make that bigger. Looks like a bunch of warnings too. Cool. All right, so let's do that again because I made a mess. If you're running commands from the console, the double dash in .NET Run separates arguments from or going to .NET Run, so arguments that you might be providing to the .NET command, and arguments that you're providing to your program. So in this case, we're passing --help as an argument into our program, which causes us to just print this. This is using the system.command-line libraries. And so there's two things that are required. There's the token and the username. The username doesn't have to align to whoever's token it is. The token is just to authenticate to the API. And then you can customize all the other things. So what we're going to try to do is make it so that you pass in a username and all this other optional information into a web service and get something back from that. So that's what we're going for. There are a few unsolved problems that I don't actually know the answer to yet. The main one is auth. I do not know the best way to handle authentication to GitHub's API from a web service. So that's something that I'm still working on. That's something that we'll probably come back to later. But most of what we're doing here, that doesn't need to worry about that. So just to kind of set the scene, that's what this is all doing. This is what the project looks like. There's currently 4 projects. 2 of them don't matter. And that's this infra project, which is managing, setting up, and scaling up infrastructure for the project. And this test project, which is empty. So the other 2 is the bookmark gen, which is the library that's actually generating an SVG image. I think it generates a string. And then the console version, which is actually all the logic that you just saw. So what that ends up looking like is this. There's a whole bunch of options declared. System.command line uses two different things. It uses options and arguments. Arguments are required. Options are optional. And they're typed. So in this case, we have a bunch of ints, we have strings, and we also have some dates. So you can actually use stronger types in order to require certain parameters to have stronger types. And what this means is that you can actually provide any date to this program, and it will try to make that work. What comes out is not always reliable, but it's a thing. So that's all of that. And then the next thing is setting up a handler, which is the complicated bit. And so this is actually taking all of those arguments, all those options that we had, and casting them into a name. And so actually providing them as a function with named arguments. So in this case, the string token has a token option up here. And so those are mapped back and forth and then passed into our actual program that gets run. So the entire point of this is it's wrapping your main method that you would normally have in a program with something else. It gives you a little bit more control when you're actually trying to do that, and makes things a little bit nicer. The other interesting thing about this project is it's using GraphQL, which is interesting. This is my first time doing it, so don't judge. But GraphQL allows you to, it's sort of a query language, unlike REST, which targets specific endpoints and returns a set response. GraphQL allows you to kind of shape your responses or by requesting specific amounts of data. So you can actually say what you're expecting the response to be. So in this case, it's a little bit weird because it's an interpolated string in this case, but we actually have we're saying, I want a contribution calendar. So the calendar of my contributions with a list of total contributions and a set of weeks that has a contribution count per day. That's what we've sort of asked for. And the API just gives us that back. And you can add new parameters onto this. There are certain things that I've excluded and so on. So you can kind of tweak this to do whatever makes sense to you. So that's that. GraphQL is interesting. GitHub actually has a really nice GraphQL Explorer, which I don't have here, but let's go and find it. GraphQL Explorer. That looked right. There we go. So this, you will need to sign in to use this, but this will actually allow you to run queries against GitHub and query the GitHub API. If you want, you can actually expand this. Let me click this button and see where this goes. That's fine. And there we go. All right, so we can actually do this. If you click Explorer, I don't know why we don't see any schema here. There we go. All right, it was loading. So we're kind of talking about a whole bunch of different things here, but what's happening here is this is all the stuff that you can go and request. So you can kind of shape your requests to grab data from all sorts of different places and collect it into a single response and come back to you and give that answer. There's a bunch of other things you can do with GraphQL. It's pretty neat. But this gives you a way to kind of play with that against GitHub and kind of poke at your own user or your own repo or the community's repos. So that's there. It's pretty cool. I'm still learning it. The advantage of doing something with GraphQL versus something like REST is that if you have GraphQL, you can actually structure how you're interacting with all these microservices that you might have. So if you're building a microservice-based system, unlike with REST, where you might have a procedural way of going through and getting all these responses, you can programmatically decide how to actually go and fetch the specific data that you need in order to fulfill that request, which means that how you're actually invoking these different services can change depending on the information that's actually needed without maybe ignoring certain parts that maybe aren't as useful for that specific query. So that's GraphQL. So I think that's mostly what's going on here. The other thing that we do is just write it out to a file, which is fine. And there we go. So there's actually ignoring all the GraphQL stuff, because that's interacting with GitHub. We'll do that afterwards. And ignoring all of the command line stuff, there's really not too much here. All this is doing is grabbing a set of data, converting it into a list of floating point numbers, and then converting those into weights, relative weights. So you have a set height and width, and then you just need to assign that. So whatever the scale is that you're traversing, figure out what that is, and then scale everything accordingly. So let's do that for a web service. So we're going to go and kind of step through these. The steps for this: create a web service. So we're going to do a .NET Web API web service. Then we're going to containerize it. So we should be able to run a container locally. And then we're going to aim for container apps, Azure Container Apps, which is a new generally available container service that lets you run container apps in sort of a Kubernetes environment without having to set up and manage your own Kubernetes environment. So that's sort of where we're going. So let's add a new project and find Web API. Eventually. There we go. So let's go and grab Web API and name it something that I will want to change in like a few seconds. So bookmarkgen.api, I think, is what we're going to go with. We'll use .NET 6, and we will do all of this. I'm going to leave enable Docker unchecked. We're intending to deploy this to container apps. That's sort of our goal. But if I leave this unchecked, we'll be able to go through that flow later. And I'm curious how that is. So we're gonna find out. It also is kind of useful because if you're doing this from the .NET API, like on a new web API, you won't get that Docker option. You won't get a Docker container. So we're going to start here and try to figure that out. So might be wrong. Is there a Docker file? I don't think so. At least I haven't seen one. So ignoring that, let's go and jump into our web API. Web API has a few different things. It comes pre-built with a weather forecasting thing. So we're going to just set it as our startup project and run it and see what happens. Let me, do that and run. And so web API is useful for creating APIs. If you need to make web requests against a service, an ASP.NET service, this is sort of the base that I would go for. And it's less focused on, say, UIs that you might have. That is not necessarily where it is. But there we go. All right, it's still starting, unfortunately. So we'll see what happens. But once we get this back, it does a whole bunch of blinky lights, and then we get a web service, hopefully. There we go. Cool. All right. So what type of API? SOAP, REST, WebSocket, REST. Probably REST. I think. I think we're gonna go with REST. I also think there's an option to do. I was reading about this. I believe there's a way to actually integrate GraphQL, which we were just talking about, into ASP.NET. I don't know how that works. That's on my list of things to actually check out over the next few weeks. And there might be a stream where we just learn that, because that actually sounded really interesting, and I don't know much about GraphQL. So when you launch a web API thing, you're going to get a web page that looks like this. This is Swagger, which is OpenAPI. OpenAPI is a way for you to just define your web services. So we, by default, this template comes with a weather forecast. So we can see the REST requests that we can make against the service. In this case, there's a GET request to weather forecast. So we can expand this. It has no parameters and a single response type that it could return. So Swagger gives you a way to document your web APIs. There's also other really fun things you can do. This is the Graphql version of Swagger. I believe there's a way to get the JSON version. I don't know the URL immediately off the top of my head, so we're not going to play around with that too much. But you can get the JSON version, which is the code version. And you can use that to actually go and generate your own APIs for different languages. So if you want somebody to be able to integrate with your API over something like Go, for example, you can actually generate an API for Go based off of a Swagger spec. So yes, it is very, very cool. I think that's pretty much getting across the point. So Swagger's cool, and it comes enabled by default. We can show you quickly where. So if we go into our Solution Explorer again and look at our program, there's actually these four-ish lines are what's actually enabling Swagger inside of our project. So if we're in a development environment, it turns on Swagger and the Swagger UI. So you have two options. What I was just demonstrating was the Swagger UI, which lets you actually explore your APIs. And then using Swagger will just generate that Swagger spec that can be used by other services to generate things that can actually interact with your service. So if you don't want to manually go and write your APIs to interact with different services, Swagger can actually generate those for you. And you can even use that for other things that maybe aren't your own services, just because you want to interact with them and they have a Swagger spec that's available. So that's super cool. Getting very distracted, but that's okay. And it looks like add Swagger gen is also in there. So if you wanted to take this out, you could just remove all of those. We're going to keep them in because it's nice. Another interesting thing, it should let us just run our web service. So here we go. We can actually just send responses or requests to our web service directly from this UI. So if you actually want to go in and interact with your web service, it's right here. And if this had a parameter, for example, we could change that and provide a different parameter. So lots of fun things. Don't know why I'm getting distracted on Swagger. We're trying to get to web apps. Anyway, so let's stop here and take a look at the other two things that are happening. This is our weather forecast. This is the result that we're getting back. So these are our models, I guess. And then the way the magic of how all of Web API works is through controllers. There's two real ways this can work. There's a new minimal API, which doesn't use any of this. You just map things directly from the program. That's an option. I've found it's nice for small things. And if you're trying to do something that's more concretely defined, it can get a little bit out of hand. So controllers give you a way to kind of more explicitly define a domain for things. It's kind of based around REST, where REST works on performing specific operations against specific types or models. So in this case, we have something that interacts with the weather. We have a GET request that says GET weather. And so that's how all of this is working. There is some fancy stuff going on here with a custom routing. So this is actually dynamically invoke or figuring out what the routing is based off of the name of the controller. So that's what that's doing. If you want a specific route, you can also define that. And then what else? It looks like there's a few different summaries of what this is. We also have a logger that's going to be dependency injected in our constructor here. So that gets injected in. And then we have our function. So the way these functions work is they are just normal methods. There's not too much there. The interesting thing is they have names, and they're labeled with this attribute that actually says what they're doing. So in this case, we have HTTP get, which means it's actually going to go and get some resources for you. There's put, post, and delete are sort of the common other options that you'll see. I believe there's a few others, but I don't use those very often. I can't list them off the top of my head. But get, put, post, and delete are the ones that you should probably know if you're interacting with REST. And the way those work is get is for retrieving resources. So typically you won't be making any modifications. A post is going to put information into, I shouldn't say put, it's going to insert information into something or perform some operation. And put is going to do the same thing. The difference is one is idempotent and one is not. So let's say you want to create a user, for example. I need to remember the direction this is. But if you're doing a put to insert a new user, that means that every time you do that, it's fine. So you can add another person to the queue, for example, if that's sort of what you're doing with a put. Whereas with a post, you're saying create this new user. And this is a unique thing. Only one of these should exist. And so because it's not idempotent, it means that it will change depending on the state of your application. And so now we've created the user, so we don't want to create another one. So the first time you run that, you're going to get a success. And the second time you're going to get a failure because the user already exists. That's the difference. And then the other one is delete, which just deletes records. So that's all for. And yeah, so for what we want to do, we want to create a get that returns our generated thing. This is going to be weird because I don't actually know. One of the reasons I wanted to do this project is I don't know how to do some of the things that we're going to do here. We need to return an SVG, which isn't a JSON response like we're probably going to get here. I don't know exactly how to make that work. So we're going to figure that out. But that'll be fun. Let's experiment with one more thing here. And that's parameters here. So there's two different ways you can kind of pass things into a web service. You can provide things in the body of the thing that you're posting. So the body is going to be, let me go and, but this is Nightingale. This is available to you if you have Windows. It's on the Windows 10 and Windows 11 stores. So it's available there. This is information about a user. Perfect. So this is a bunch of information from a PlayFab thing for games. So there's different ways to actually send information up here. And it looks like we're doing both of them. So that's perfect. So the two ways you see here is you can have a JSON body, which is going to be an object defined here that you're going to just send across as like a blob of data. And this doesn't have to just be JSON data. It can be other things too. JSON is pretty typical, but this is how you would send more information. The other thing, which you might see in your browser, for example, is parameters or query parameters. So these are actually just tacked on to the URL. So if you ever grabbed a link and you wanted to share that with somebody else, that's what's going on here, is you're actually grabbing part of those URLs and sharing those as well. And in this case, there's a single one for a code. I can't zoom in, unfortunately. So it's a little small. But in this case, there's a code here that we're using to actually apply to this. That code is being used to as a query parameter. So it's just authenticating or providing specific information here. And then it's not unique. So yeah, and that's all that. So to do that, you can just add things here. Let me make sure I'm not screwing this up because it's been a while. So let's do a float time. That's a weird choice for a time signature thing, but we're going to try it. So if we add a time here, we're not actually going to do that. I'm expecting this to show up in our Swagger spec. So we should actually see this pop up into here. And so now our parameters has a time attribute here. So we can actually, if we click try it out, we now have time, and we can change this to something like that. And it's a float, so that's probably not going to work. Actually, if we try that and say to execute, Swagger is going to give us an error. But we can set it to 1 and run this. So there we go. If we don't want to use this through Swagger, just because we might not want to, we can also just grab this URL here and paste it into something like Nightingale. There's also Postman and a few other ways to actually interact with your REST requests. So let's go and create a new thing. Go here. You can see the query parameter gets added. So query parameter of 1. Let's change this to test. So this is no longer valid. This doesn't match what we're expecting to float. And so we get a 400 error with the value test is not valid. So we already have authenticate or author. Those are all the wrong words. Our values are already being validated by our service, and we didn't add any of that in. So I already have a really nice error. I didn't have to do anything, which is great. So let's kind of go and make our own controller now, because we've kind of been meandering forward. I'm trying to keep this at somewhat of a, I don't even know. We're kind of bouncing around all over the place, but that's okay. I'm trying to kind of cover every bit just so that it's hopefully clear. If we go and add a new controller here, we should get something empty. So let's go API controller with read-write actions. Nope, just an empty one. And let's create bookmark controller. So naming here, actually, there is some standard, I guess, which is to put things behind or have controller as sort of the postfix of your class names. So when you're naming things, having bookmark and then controller, and then having it implement the controller base. There's a few things that I want to grab from this existing weather forecast one. And that's mostly this. So what's happening here is there's actually a logger that's created and injected into these controllers for us. So you can add more of these if you want. This is a somewhat more complex thing, but it's called dependency injection. So what's going on here is an inversion of control where instead of saying this thing is going to log out to a console, or this is going to log out here, or write messages here, and having to program that into the controller, instead we're saying this controller just expects to be able to log messages. That's it. And the application is going to tell it where to log those messages to. It's going to provide the implementation of that. So that might be different than you might see. I really like this pattern, and some people really don't. So depending on your style of engineering, it may change. For services, dependency injection seems really nice. And you can also inject your own things. It doesn't just have to be this logger. You can declare them in your program step up here. So you can actually just add more and more things as you need. So if you need to inject additional services, you can do that, and then they'll automatically end up in your service. So now that we've gone on even more tangents, let's go and talk about this. So this is ending up in a different place under API/controller, which is not API/controller, it's API/bookmark, because bookmark is the name of our controller. So let's just quickly add a get method onto this. So let's grab this and go to our bookmark and paste that. And we're going to call this get bookmark. Sure. And it's going to return something. Probably a weather forecast doesn't really make a lot of sense, so we're not going to do that. We're just going to return a string for now. Right? String? Sure. Let's do a dictionary of strings with floats. Why not? And so I'm just going to create this quick, just so we have something. And there's somewhat of a point to doing something a little bit more complicated. So if we just do test 1 and 2 and 2, there we go. Just some quick like test data. This is a bookmark or dictionary constructor. If you need to quickly create an initialized data in a dictionary, this is the way to do it. But if we go and run this now, let's just restart. What this should do is now create another endpoint for us to actually interact with. And so now we have two. We have API/bookmark and API/weather forecast. No API. I personally prefer putting things behind API. That makes it a little bit less confusing if you actually add a front end onto something. So it's again, it's all up to you. But my personal preference, all you need to do to change this is modify your routes. So if we go in here, you'll see there's a few different things. And it even automatically gives us a example of the response. That's neat. But let's go and test this. And we get actually a JSON formatted dictionary. So the important thing here is also the JSON serialization is happening automatically for us. We're not doing it. We're not doing any of that. So that gets done. And now I guess we do the serialization. So we've done that. There's 2 steps, I guess we have, and sort of a choice to make. Our goal is to integrate this library here, this bookmark generator, into this API. It's also to containerize it and deploy it to Azure Container Apps. So we can actually do either of those because they don't actually depend on one another at all. So we can do either one we want. I'm thinking we actually start with containerizing this. I think that'll be a more fun thing to start with. So let's try that. The advantage of containers, the reason that we like containers, or that I like containers, is because it makes your code reusable. It creates this unit of code that you can just go and say, run this, and it will be your service. You might have run into issues, especially if you use like a interpreted language that's done at compile time or runtime. You might run into things where it works on one machine and doesn't work on another. Containers can largely avoid that because they can isolate systems into a single container. So this means that instead of all of your stuff running simultaneously in the same thing, maybe overwriting to the same file for logs or doing something else, maybe trying to access the same resource, instead of that happening, you can isolate everything into its own little container, and all of that other stuff will kind of be specific for whatever is running there. And so it gives you this nice isolation. It's not quite the same isolation you would get from something like a VM, for example, which is significantly more isolated, I guess. But the advantage is it is there. So you can actually create these things and then create a container that can then be taken by most other places and just run. So you can go and run this in Kubernetes, or go and run this in Azure Container Apps, or go and run this in Azure Function, or run this locally in your own Docker or container runtime. However you want to do it, they should all work. You can even run it in something like a GitHub action if that's what you want. So let's figure out how to add a container. I think there's a way to do this, but I don't actually know the way to do this. I've recently switched back to using Visual Studio instead of Visual Studio Code. So figuring this out as well. Let's go and see if there's a Docker file. If not, we can go and find a... Let's go and find a example, because I don't see a thing here either. I was kind of hoping I'd be able to just click something. I remember seeing something previously, so I thought it would be clever if I didn't do it. But I don't. So let's, I guess there's two options. There's the one we can go and find a container reference. They have a few of those. Or what we could do is stop this. Maybe that's part of the issue. And create our own container that way. So we can actually just go and create another project and follow the same thing. I don't think those are what we want. And there we go. Add Docker support. So if I was running the app, it was currently running, so I didn't see these options. But we can add a container orchestrator or Docker support. Container orchestrators are things like Kubernetes that actually can manage containers at scale, whereas something like Docker is a container runtime. And Docker is also like a container engine, which is a bunch of words to say it runs your containers. And container orchestrators take that runtime and spread it out so that you can actually run this a lot. So you can scale these. They can network together, and they can even span multiple machines. So let's add Docker support. There's two different OSs for containers. We're going to choose Linux here. You can choose Windows. There's nothing wrong with that. You're just going to get a slightly different image. And Windows images tend to be larger than Linux-based images. I would recommend Windows if you have specific things that you need in a Windows environment. Maybe you're running .NET 4 that requires Windows, or you need something like IIS that actually requires to run on Windows. If that's what you need, then I recommend that. Otherwise, stick with Linux. So there you go. And so this is going to create us a Docker file. This is not the simplest Docker file you might have ever seen. But what this is doing is actually creating a series of layers to actually build your image. So it looks like you have a base image here. So this is creating based off of the ASP.NET 6 image. So that's what this from clause is saying, is grab an image based off of this existing other image out in some container registry, which is just some container app store. So you go and grab that. And then we're just giving it a name, calling it base, so that it can be referenced later. And then we do that 3 more times. We also create something and call it build. This is pulling in the SDK. The other one is publish, which is pulling in the build image. So build creates this whole thing, builds our project, and then publish actually pulls all of that in and publishes the full project out. And then the other thing is our final image, which is based off of our base image. Now, this is complicated for a few reasons, and the main reason this is complicated is because it's separating out your SDK from your .NET runtime. Which what that means is that your published image won't be able to build .NET, but it will be able to run it. And so that's sort of the advantage you get, is you get a smaller image because you're not shipping all of the stuff you need to have the .NET SDK installed in a container that's intended just to run your service. So that's what's going on. That's why it's confusing. And that's why there's so much here. These two are sort of building all of that. And then this final one is just taking that published image and actually pulling that publish file from there into itself and then running it. So Yeah, it's a thing. So let's see if this runs. I'm skeptical. We'll see. So if we run this, I'm curious if this is going to work with our project dependencies, because I didn't really see if it would or not. And I'm also curious, do I have my container running? I do. Okay, good. So we get the same thing we had before. How do we know it's running in a container? Is it running in a container? So the way that we do that is we do Docker PS. That's going to list the processes that are currently running. I have two. Currently, I have a kind cluster. So let's get rid of that. Ignore that. That's a kind is a Kubernetes and Docker. Lets you run Kubernetes clusters inside of Docker. That's just old. And then this is our actual bookmark API. So if we do this again, we'll now just have the one. And so we actually have the 2 ports that we're currently accessing this. Do I have my own personal Twitch channel? You've asked this before. And the answer is yes. But mostly we're focusing here for now. So thanks for asking. But yeah. So let's see here. The 2 ports that we have here are going to be our HTTPS and HTTP. My terminal theme is not Z shell. It's actually oh my posh. Let me do this if you're curious. I think this is safe. We'll find out. I might need to cycle some things. But we'll just pull up my terminal profile. There you go. So there's a few things going on. The flag in the background is actually a shader, which you won't see here. But most of the interesting things are coming from Oh My Posh, and then the terminal icons, and the Posh Git is also kind of helpful. Then there's also a custom color scheme that I use. And the whole thing is in console or Cascadia code, the Powerline thing, with added nerd fonts. Anyway, that's maybe another discussion. But yeah, if you would like more information about how I set up my terminal, ping me, and I will help you set yours up just like this. So there we go. What else? Yeah, getting distracted. Representation matters so much. I used to use oh my Z shell. Sorry to interrupt. No problem. That's sort of why we're here. This entire show is called the Reactor Code Lab. The entire point is more of a conversational style where I find something that I'm like, I want to learn that, and we go and learn. So that's why we're here. So these kind of conversations and kind of going off and talking about the interesting bits are why we're doing this. So if that's cool, then awesome. But yeah, if you do want to learn more about this, I actually have a blog post about the shader thing that will get you started on all of that. I can send you that if you'd like. Have you done the Maui stuff yet? I have not. I've done very briefly. I've poked at Maui. Next week on Wednesday at 4 p.m. 4 p.m. Pacific. Sorry, we're actually diving into .NET Maui. I'm getting taught by somebody who has a lot more knowledge than me. So if you want an hour of me learning Maui, we're doing that next Wednesday. So at 4 p.m. next Wednesday. So if you want to see that would be cool. So that'll be me trying to figure out how to take like Windows Phone knowledge that I've had for years and really old WPF stuff and learn some of that. And hopefully, if we get to it, build something for a Surface Duo, because that's what I want to get done in that hour. So we'll see what happens. Very distracted, but this is awesome. we have our container running. So the only real difference between adding the container support versus just running the app is that now we can see the app running in Docker. That's the difference. It also means we can actually rerun this. If I always forget the command for this. Oops. Images all. There's some way to do this. I forget. There we go. So this is way too many images, but our newest image is here. So there's actually an image that we can actually reference and use if we're trying that. Hello from Brazil. Hello, I am in Oakland. Hello from California. So that would be, yeah. Okay, cool. Getting even more distracted. This is great. So a few different things are going on here. One, this image is huge. I don't know why it's 208 megabytes, but it's big. I think this might just be coming from this ASP.NET image. It's generally with images, you want to keep them small. And the overall size doesn't so much matter. So in this case, this is not going to be a big problem for us because the size of this image is almost entirely tied up in this one, in this ASP.NET image. The reason that's not a problem is because Docker builds things in layers. So when we're building our container, the way this works is we say we want a base image. So we're going to take Ubuntu, and then we want to add this SDK in. So we're going to add the .NET SDK in, and then we want this dependency. So we're going to add that in, and then we're going to add in our code, and then we're going to build our code, and then we're going to publish our code. And it just keeps adding these layers to whatever it is. And as long as those individual layers are small, especially the further in you go, the better. Because what ends up happening is if anything changes up that stack, everything below it needs to get rerun and needs to get changed. So what you can end up doing is if you have really large images, if you start shipping these large images with very large layers between one another, you're now sending gigabytes of data in order to start your app, which can in fact impact how quickly you actually start whatever it is that you're actually trying to run. So there we go. Yeah. Okay, cool. We have our container. The next step, we've gotten all over the place. But the next step is to actually run this container and push it out to a container registry. So we've already done that. We already have it in a container registry. It's on my computer. But container registries in general, for example, if we're talking about in Azure, are things that are actually accessible by either everybody, which means literally everybody, or can be accessed by you and other people with access to that container registry. And so this actually gives people a way to actually just spin up this thing. So typically, we're starting up a Kubernetes cluster, for example. That's going to reference a specific container registry. Same thing with the container app. We're going to want it to reference a specific container registry in order to actually set that up. I think we have two different problems to solve. I definitely can't solve the how do I get an SVG to return from this, because I don't even know where to begin. Because everything that I can think of is going to return a string, and then that won't work. So I need to think. There's a few problems that I need to think on this. We're not going to end here. We're going to probably continue this at some other point throughout June. But the idea here is we need some way to return something meaningful. And I think you can do that. There's a way to, right now we're returning a specific data type, like a dictionary. You can actually return, I believe it's HTTP response. Response equals that. What does this do? So we can actually set things here. So maybe this is the way to do this. We do have 10 minutes, so I could probably figure this out in 10 minutes. Let's give it a shot. So we're going to try to return something meaningful from this. I'm going to skip all of the hard bits, and we're going to format content type. What is this? That's not a setter. Let's do. Oh. Okay. So not like that. XVG. I don't think that's right, but we're going to go with it. It also doesn't like my fancy constructor. This is an abstract type. Okay, so let's go and figure out how to return an HTTP response. So web API, C# HTTP response. Sure. So we're definitely not going to get to the Azure Container App stuff. If you want to learn more about Azure Container Apps, we're talking with the team from that project on Monday, next Monday, at 4 p.m. So next week, we're kind of walking through a number of different things that were announced at Build and talking with some of the teams and sort of diving into some of the tech that came out there. So if that's something that you want to learn more about and maybe you missed Build or you just want to hear from some of the teams to kind of dive a little deeper into why these things are cool, I'm diving into Maui and Azure Container Apps, and a number of my peers are also diving into other really fun and cool things. So that's happening all next week. So if you want to do that, there's a link. Yeah, I'm just saying that because we're probably not getting to Azure Container Apps. My goal is to kind of get there. I might do that off stream, or just do an impromptu stream sometime. But let's see here. Examples. Let's see. It's formatted set to JPEG. Perfect. So we can actually use that if they're returning a JPEG from this. This looks complicated. Okay, that's not what I really want though. Response wrapper, response base. How to use HTTP response in .NET or ASP.NET. There we go. Web API. And feel free to chime in if you're familiar as well. I'm trying to show a little bit of how HTTP response message. What's that? Go and find out. This looks like what we want. It's a disposable class with all sorts of fun stuff. All right, cool. So it has content, which is perfect, and do we want headers? There needs to be a way to return a response type, because the default response type from .NET Web API is going to be JSON, and I don't want it to be JSON. That's going to cause issues, because we're trying to return our fancy thing. Response message. If this new, what I'm doing with the new is a little bit confusing. This is actually a amusingly new thing. So what that does is infer the constructor from the left-hand side. So similarly to how like var would infer from the right-hand side, new is inferring the type from the left-hand side. So it's just a different way of writing a constructor. It's the same thing as doing something like this. So if I get the order right, there we go. It's the same thing. Both of those are doing the exact same thing. The only difference is where all of your code is. And this is actually slightly longer, just because we had to add the var in. And the nice thing with this is all the types end up on the left-hand side. So it's just a stylistic thing, but it's a thing. So we get our message. Let's tweak this and set this to have a few different things. So content equals, and let's do I'm getting confused because I want to do a perfect. All right. Can't convert to HTTP content. Oh, okay. That makes sense. Okay, so this is not a string like I was assuming it was going to be, or a object. It's actually strongly typed to HTTP content. So what's this? No, we're going to need to figure out how to do those too. So let's go and find an example for this. So let's go down to content and see if we can find an example. String content. Sure. So there's also stream content, which I think is what we want for an SVG. Again, the reason we're running into this is I want to return an image. And you can't do that in JSON. So I'm trying to figure out the best way to do this, and I honestly don't know. So we're figuring it out. Looks like string content has string and encoding. A stream content has a stream and an in32. And then there's sockets. I don't want to mess with sockets. Read-only memory, and then a few others. And then the HTTP content is just something else. So let's start with string, and then I will figure out what I actually intend, and then we'll move on from there. So let's do this, and really what we're going to end up with here is basically what we were getting previously, just more messy. New string content. The string, we'll just say hello world. And so I'm going to just do string world equals world. That's a really weird way to write that. But we're going to do that. So there we go. So we have new string content with our content, and then we can return that instead. So if we return our message instead, how does this work? So let's say we're going to return an HTTP response. So we're just saying a generic HTTP response is going to be the result of this. And then message is not null. I know. Oh. Do these not implement the same thing? Or am I confused? I might be confused. Oh, because this isn't implementing the HTTP response. I made a mistake by assuming it was because of the content. So this might be a whole, I need to go and figure this out. There's a whole bunch of things that I just don't know. I'm really bad at auth, and I need to figure out how to authenticate with GitHub servers so I can make web or API requests against it so we can generate the thing we're trying to. That's, I guess, something I need to figure out. I also need to figure out the best way to actually do these SVGs. So I'm going to go and figure that out over the next week or two, and then we can probably come back to this and finish it all up. And then you'll be able to actually make your own Git markers or whatever I'm calling these things, which is just a bookmark with your GitHub activity because it was cool. So I think we're kind of out of time, so I'll kind of wrap it up here. If you do want to hear more about some of the build stuff we're doing, that's happening next week at 4 p.m. on Monday. I believe 9 a.m. There's a link that's going to have all of the correct timings, and that will be there we go. that will be a little bit more helpful. So if that's something that you would like to kind of catch up on and learn more from the actual teams that built some of these things, feel free to do that. We'd love it if you'd come in and join and ask questions. So please do. Otherwise, I'll get to learn some stuff. We do have a survey up there that lets me know how I'm doing. So if you fill that out, we'd really appreciate it. It just gives us some feedback on if we're on the right track or maybe not so much. So other than that, feel free to reach out if there's other things. I know a few people had questions, so happy to answer those if you want to follow up. So yeah, thanks everyone, and appreciate you all.
Thank you, Sam. Thanks everyone for joining. Until next time, have a great one.